In this class, we solve a problem from dynamics of a particle and from the projectile motion. And the problem is, if any number of particles are projected simultaneously from the same point with equal velocities in the same vertical plane, same point, same velocity, but number of particles. Okay. Prove that at any instant the particles all lies on a circle. We draw a rough sketch of any one particle. Let this be the projectile. And the velocity is same for all the particle u, but this may be different. This is the angle of projection. It may be different for different particle. And let alpha be the angle of projection. So initial velocity of projection along x-axis, this is u cos alpha, and along y-axis is u sin alpha. This is y-axis, this is x-axis, this is the point of projection. This is origin and it is 0, 0. At time t equal to 0, x equal to 0, y equal to 0, x dot equal to this, and y dot this is equal to u cos alpha. These are the initial condition. And at any point p, let the velocity of the particle along the tangent, here only one force, this is g, or it may be written as minus g, acting vertically downwards direction and per unit mass. So the equation of motion of the particle at any time t at xy, at any time t, we get the equation of motion are x double dot, this is equal to 0 because there is no force along x-axis, and y double dot, this is equal to minus g because there is only one force and this is negative direction of y-axis, right? And this is 1, this is 2. From 1, by integrating, we get x dot, this is equal to c1, and we put the initial condition x dot equal to this, t equal to 0, x equal to 0, y equal to 0, we get c1, this is equal to u cos alpha, and this means x dot, this is equal to u cos alpha. Again integrate with respect to t, obviously this is x equal to u cos alpha into t plus c2. Again we put the initial condition t equal to 0, x equal to 0, and clearly c2, this is equal to 0, so we get x equal to u cos alpha into t. Let this be 3. And from the second relation, by integrating, we get y dot, this is equal to minus gt plus c3. And using the initial condition t equal to 0, y dot equal to u sin alpha, we get c3 equal to u sin alpha. And putting the value of c3, we get y dot, this is equal to minus gt plus u sin alpha. And again integrate this relation, we get y dot, this is equal to minus gt square by 2 plus u sin alpha into t plus c4. And using this initial condition t equal to 0, x equal to 0, y equal to 0, we again get c4 equal to 0, that is y, this is equal to minus g t square by 2 plus u sin alpha into t, and this is known as 4. And here it is says that at any instant, let the instant be t equal to capital T. Then capital T must be constant, and we put small t equal to capital T. Then from 3 we get x equal to u cos alpha into capital T, and y equal to minus g t square by 2 plus u sin alpha into capital T. And this relation gives y plus gt square by 2, this is equal to u sin alpha into capital T. Right? Now these two relation. From these two relation, by squaring and adding, we get x square plus y plus gt square by 2 whole square. This is equal to u square t square into sin square alpha plus cos square alpha. So we get x minus 0 whole square plus y minus gt square by 2 whole square. This is plus, this is equal to u square t square. Obviously, this is a circle with center at 0, minus gt square by 2, and radius is u into t. This is the radius of the circle and this is the center of the circle. And we say that all the particle at any instant t lies on a circle. Okay, this is very important and easy problem of projectile.